Ramanujan for G is now available on the Google Play Store. Try it out for free.
Yeah. So, good morning, students. So, in the previous lecture, we have gone through all the basics of probability and so definition like what is simple events, compound events, executive events, mutually executive events, experiment, sample space. What is space? Okay, and we have gone through the basics of sets, right? So, today, today, we're gonna start with the main concept of the probability, like a mathematical definition of the probability. Correct. Just a minute. Okay. So today we'll start with the mathematical definition of probability. So let me write the topic name: mathematical definition of probability. Okay. So first, let's the outcome of an experiment consists of n executive, mutually exclusive, and equally likely cases. Okay, so then the sample spaces S has an n sample points. So if an event A consists of m sample points, means means 0 less than m less than n, then the probability of event A is denoted by P of A, correct, and is defined to be m by n. That is, PA is equals to m by n. Correct. So let's again, S is equals to A1, A2 up to AN be the sample space. So P of phi is 0 by n is equals to, first we'll go for the P of S first. P of S is equals to n by n, which is 1, corresponding to this certain events, correct. So P of phi is equals to 0 by n, so this is also 0, so this is corresponding to the null event. This is null event. Okay, null event phi. So if A is equals to A1, that is I is equals to 1, 2 and goes up to n, then A1 is the event corresponding to the single sample points A, then we can write P of A1 is 1 by n. That is 0 less than equals to P of A less than equals to 1. Correct. So we can say if it solves for 0 less than m less than n, that is 0 less than m by n less than equals to 1, that is 0 of less than P of A. Means probability always lies in 0 to 1, both including. Okay, so that we can write P A dash is 1 minus P of A. P A dash will be 1 minus P of A. So if the event has an element, then A dash is, if event has, if event A has m elements, then A dash has n minus m elements. Correct. So finally, P A dash is equals to n minus m by n, which is 1 minus m by n is 1 minus probability of A. Okay. So this becomes our answer. So we will look at some examples. So first you need to copy this, all this part. This is very important with respect to the mathematical definition of the probability. Okay. So first copy it. Okay, then copy this page also. Sorry. Okay, so now we'll look at examples. So question is given, two dice are thrown at a time. Two dice are thrown at a time. So you need to find the probability of following. Okay, first is these numbers shown are equal. Second, the difference of numbers shown is 1. Okay, so let's solve this problem first. Okay, hello. Okay, so S is equals to 1, 2, 3, 4, 5, 6. These sample spaces again. Second is 1, 2, 3, 4, 5, and 6. These are two sample spaces given for both the dice. Okay, so total number of cases ns is 6 into 6, which is 36. Which is 6 into 6 is 36. Correct. So now here we can write first even. This even is the event showing equal number of both dice. Equal number of both dice means you can write 1 1, 2 2, 3 3, 4 4, 5 5, and the 6 6. So n of even, which is 6, 1 2 3 4 5 6. So you can write probability of even is n even by n of s, that is 6 by 36, which is 1 by 6. So this is our first part. Correct. Now let's move to the next part. E2 is the event of showing number whose difference is 1. Means we can write 1 comma 2, 2 comma 1, 2 comma 3, 3 comma 2, 3 comma 4, 4 comma 3, 4 comma 5, 5 comma 4, 5 comma 6, and 6 comma 5. Here differences are 1. So total n of E2 is equals to 10, and probability of E2 is n of E2 by n of s. So that is 10 by 36. So we can write 5 by 18. Okay, so this is the answer for second. So copy both the parts. Sorry. Copy this second page. Okay, so let's look at one more example. So if three cards are drawn from a pack of 52 cards, if three cards are drawn from pack of 52 cards, so what is the chance? What is the chance that that will be queen? Okay, what is the chance that will be queen? So here what we need to do, if the sample space be S, then n of S is equals to the total number of ways of drawing 3 out of 52 cards. Correct? 3 out of 52 cards, that we can write 52 C3. Correct? So let A be the event. A equals to the event of drawing queens, drawing 3 given queens. So that is A is 4C3. Total there are 4 queens and we are going to draw 3. So probability of E will become n of A divided by n of S, that is 4C3 by 52C3. So solving you will get 4 by 52 into 51 into 50 divided by 3 into 2. So solving you will get 5525. So this is our answer for the first. Okay, means the given question. If 3 cards are drawn from the pack of 52 cards, what is the chance that will be a queen? Okay. Next, you'll copy later. First, let me do one more problem here. Words are formed with the letters of word peace, P-E-A-C-E, peace. So find probability that two E's come together. Okay, so in this question, first we will look at total number of words which can be found with the letters piece. Okay, so we will write total number of words which can be found with letters piece, which is 5 factorial by 2 factorial, which is 60. Again, number of words in which two e's come together, which is 4 factorial. So this is 24. So requested probability is 24 by 60, which is 2 by 5. Okay. So this is our second problem. So first you copy these two problems, then we'll look at one more problem. First copy this one. This third question is very important question. Okay, so let's look at the one more example. A bag contains 5 red and 4 green balls. So for balls are drawn at random, then find the probability that 2 balls are of red and 2 balls are of green color. Okay, so first we will write the sample events. So total number of ways of drawing 4 balls out of 9 is 94. Now if A1, the event of drawing 2 red balls out of 5, then for red, so it becomes 5C2, correct? A2 for green, which will be 4C2, because we are solving the event of drawing 2 greens ball out of the 4 greens ball. So n of A is equals to n of A1 into n of A2, correct? Which is 5C2 into 4C2. So probability of A will become Na by Ns, which is 5C2 into 4C2 divided by 8C4. So solving, you will get 10 by 21. Okay. So first copy this, then we'll do one more concept. Okay, so now take look at one more concept. This, odd against and odd in favor of an event. Odd against and odd in favor. So in this, what the concept says, let there be m plus n equally likely mutually exclusive and exclusive cases out of which an event a can occur in m cases and does not occur in the n cases. Means occurrence is m is equals to m plus n. Got it? So this is the probability for occurrence. And if we go for probability for non-occurrence, occurrence, that will be n by m plus m. That means probability of A is probability of A dash is m is to n. Okay. So we can conclude odd in favor of occurrence of an events are defined by odd in favor, which is m is to n, that is probability of A dash, and odd against is n is to m, that is p a dash is p of a. Correct. So this is the concept for the odd against and odd in favor. So first let's look at one example. In a single cast with two dice, in a single cast with two dice, find odd against drawing 7. Okay, so here events are 1 is to 6, 2 is to 5, 3 is to 4, 4 is to 3, 5 is to 2, and 6 is to 1. Okay, so probability of E is 6 divided by 6 into 6, which is 1 by 6. So odd against is 7 given. So probability of E bar by probability of E, that is 1 upon 1 minus 6 by 1 by 6. So that is 5 by 1. So ratio is 5 is to 1. Okay. So you can copy this. First, you need to copy this concept because this is important one. Okay, so uh, let's look at one last question and then wind up the lecture. So you need to find the odds in favors of getting a king when card is drawn from a well shuffled pack of 52 cards. That means 4c1 by 48c1 is because we are drawing four cards, correct? 4c1, four cards of king, 4c1, and remaining are 48, so 48c1. So it becomes 44 by 48, 4 by 48, sorry, 4 by 48. So it will be 1 upon 12. So this is simplest one. Okay, so you can copy this. Next lecture we'll start with the additional theorem. Okay, means we first will look at the general form of the additional theorem, then the special additional rule. Okay, and then we will proceed further to look at examples and the multiplication theorem and all these things. Okay, so first you need to copy this example, then we'll wind up the session. Okay, so thank you guys. We'll see you in the next class.